Today, we are going to be dissecting the concept of optimum product mix decision. Before we dive into discussing the lecture for the day, so far, so good. We have covered 3 different topics. We started with operating statements, where we discussed marginal and absorption costing. We then moved to discussing relevant costing for decision making. Then, of course, last time we completed short-term decisions. Under the short-term decisions, we discussed deleting of a segment, make or buy decisions, and also special order. Today, we are going to be looking at optimal product mix. This topic will take us for the next 2 periods, hopefully. Let's see how far we can go today. There are 4 different questions which we are going to test under this topic. So my plan today will be to do 2, then the remaining 2 in our next class. However, wherever we stop today, we continue for next time by the grace of God. All right. So what do you mean by operating statements? So we are going to talk about the introduction to operating statements. What are the types of constraints in relation to, sorry, I said operating statement. We'll discuss the introduction to optimal product mix. Thereafter, you will learn about the 2 types of constraints. Then the procedures involved in allocating scarce resources, where there is key limiting factor. Then finally, we begin to have illustrations. Therefore, what do you mean by operating? What do you mean by optimal product mix? Right? Now, before we begin to talk about this, when you talk about optimal product mix and then linear programming, one thing should cross your mind, that the company does not have sufficient resources to produce. Therefore, the little that you have, you want to allocate it in such a way that will enable you to maximize production or profits. That is the intention of the management. That's the major thing as far as optimal product mix and linear programming is concerned. Now, when you talk about optimal product mix, we said it represents the process of allocating the limited scarce resources among competing product lines in a judicious and efficient manner in order to achieve the organization's contribution, or in order to maximize the organization's contribution. That is what optimal product mix is concerned. The process of allocating limited scarce resources among competing product lines in a judicious and efficient manner in order to achieve the organization's contribution. It should be noted that optimal product mix is used when only one constraint or only a single constraint is limited in supply. When only one factor of production is limited in supply, that is when you apply optimal product mix in achieving a production plan that will maximize contribution or profit to the organization. Therefore, when a company does not have sufficient factor of production, including raw material kilogram, labor hours, or machine hours, to produce the company's final products in order to maximize contribution or to take advantage of market condition, the limited scarce resources, the limited available resources will need to be allocated among the competing product line. Okay, so this is what we mean by optimal product mix. It involves finding appropriate production mix that will maximize total contribution for the company, because the company wants to take advantage of market condition. Customers are demanding for products. Customers want to buy. The customers want to buy, but the company has limited supply. It has limited product to sell to the customer. Therefore, the little you have, the little resources you have is what you are going to produce in order to satisfy customer demand. Therefore, how you are going to allocate these little resources that you have that will enable you to maximize contribution is what we are discussing as optimal product mix. Now, you have to be very careful, because on the day of your exam, this factor of production we are talking about will not be given to you directly. When you talk about factor of production, when a company wants to manufacture or a company wants to produce, you are going to need raw material kilogram. You are going to need labor hours to produce. If the production is machine intensive, then you are going to need machine hours for the purpose of satisfying customer demand. But on the day of your exam, material kilogram may not be given to you. Labor hours may not be given to you. Examiner will give you material costs. You are going to be given labor costs. So you have responsibility to convert this material cost and labor cost to material kilogram and then labor hours. I will show you how to do this later on. Now, we said that optimal production mix, the optimal product mix or linear programming arise as a result of insufficient resources. The company does not have enough factor of production. That means there is a constraint, or what we call limiting factor, or what we call bottleneck, right? So let's talk about limiting factor and what are the types of constraints that can arise. Now, when you talk about limiting factor, like I said, it's also known as bottleneck or constraint. It represents the factor of production that is limited in supply. It arises when a company does not have sufficient resources, which impair the ability of the company to take advantage of market condition. All right, any resources or any resource within the organization that limits the ability of the company to take advantage of market condition or to maximize contribution towards profits is a limiting factor. It's a constraint. All right. So that's why we are saying that a limiting factor is anything that stands on the way of achieving a particular goal or objective. All right. Anything that stands on the way of achieving the organization's objective is a constraint, is a limiting factor. Now, for the purpose of manufacturing a product, there are three kinds of constraints that may arise. Like I mentioned earlier, when a company wants to produce, you are going to need raw material kilogram. So when there's inadequate raw material for production that will satisfy sales demand or customer demand, yes, this is a constraint. Also, labor hours can be a constraint because it can restrict or limit the ability of a company to produce the required resources, to produce the required quantity of that particular product. When there's insufficient labor or employees that have specific skills to do the job, so this will involve, this will amount to a constraint because you are looking for particular skill to do a particular job. but that skill is not readily available. That's a constraint. That means the little you have is what you are going to make use of. So that's a constraint. Constraint can also arise whereby maximum capacity of machine hour may limit the ability of the company to produce the required products or the required quantity of a product to satisfy customer demand. All these things are constraints that we are talking about because you don't have sufficient. So the little you have is what you want to allocate out. Now, what are the two types of constraints? Basically, there are two types of bottleneck or limiting factor or constraint in relation to optimal product mix or linear programming. The first one is single constraints, and the second one is multiple constraints. Now, the single constraints arises whereby only one factor of production is limited in supply. So when only one factor of production is limited in supply, we said it is a single constraint. For example, if raw material may not be sufficient to produce, but other factor of production or other resources required to produce will be readily available. So like I said, if raw material is not sufficient, that's a constraint, but other factors like labor hours or machine time will be sufficiently be available for production. So only one constraint is limited in supply. The second one is multiple constraint. Where there is multiple constraint, it means that more than one factor of production is limited in supply. So under this situation, when there is multiple constraint, you cannot use optimal product mix. You cannot use the key limiting factor for the purpose of allocating limited scarce resources. In this case, you are going to use linear programming for allocating limited scarce resources. So linear programming is more suitable for allocating limited scarce resources when there is multiple constraint. For example, raw material kilogram may not be sufficient and labor hours may not be adequate. So when this happens, then for you to be able to determine the optimal production plan, you will need linear programming method for the purpose of allocation. So we are going to discuss, after optimal product mix, we are going to be discussing the linear programming. But right now, our focus is on the single constraint. So like I mentioned, when there is single constraint, the key limiting factor is used for the purpose of allocating the limited scarce resources. Under single constraint, the key limiting factor is used for the purpose of allocating limited scarce resources. Therefore, what are the procedures to carry out anytime you want to allocate limited scarce resources? Specifically, there are about 7 different procedures that you need to carry out anytime you want to allocate limited scarce resources under single constraint. The first step is to identify the key limiting factor. The first step is to identify the key limiting factor. How do you identify the key limiting factor? This can be done by comparing the required resources with the available resources, whether it will result in a surplus or shortfall to the organization. I repeat, to identify the key limiting factor, the most important thing to do is to compare the required resources with the available resources, whether it will result in a shortfall or surplus to the organization. If the available resources is more than the required resources, it means that there is a surplus. But if the available resources is less than the required resources, that means there is a constraint. But if there's a surplus, do nothing. You don't need to do anything because for example, you need 100 kilograms to produce, but you have 120 kilograms. That means you have a surplus. In this case, there's no constraint. Provided there's no constraint, do nothing. But when the required resources is more than what you have available, that's a shortfall. That's a constraint. When there's a constraint, then you have to carry out the method of determining the optimal product mix. That's the first thing you need to do. You identify if truly there is a constraint by comparing the required resources with the available resources, whether it will result in a shortfall or a surplus to the organization. How do you do this? Let me show you the table. The table below can be used to confirm the insufficiency in the, let me look for space. I don't have, okay, let me just manage somewhere here. Let me see if I can manage this small space. Okay. Now, what we are saying is that because this step one is very key, oftentimes, examiner will tell you that raw material kilogram is not sufficient, labor hour is not sufficient. But at the end of the day, when you carry out this first step, you discover that there are surplus. So, and that's why this first step is very key. You have to carry it out for you to be able, because you don't follow what the examiner is telling you. The fact that the examiner is telling you that there's a constraint in labor hours or material kilogram does not mean that you have to believe that. It is your responsibility to be able to carry out to confirm the insufficiency in the key factor. So to determine the key factor, so you are going to apply this, you are going to use this table. So you can say confirmation. This is for the first step. Confirmation of insufficiency. I hope this space will be sufficient for me. Let me just manage it. I don't want to use the working note for now. Confirmation of insufficiency in key factor. Let me push that to the front. In key factor. The key factor is that resource that is limited in supply. It could be labor hour, it could be machine hour, it could be labor, it could be material kilogram. So the first thing, your first column will be the products. Next column will be the unit demanded. Then the next one is key factor per unit. Then the last column will be total key factor. Don't forget what I said. This key factor could be material kilogram. It can be labor hour or machine time. Whatever it is, examiner will surely give you a clue. You are going to be given a clue in the question for you to be able to know whether material is the key factor or labor is the key factor. Surely examiner will mention it for you. So let's say we have product A, B, and then product C. All right. So let's say we are given the units. These are the units for each of the products. The units produced and sold. Now, the key factor per unit, you are the one that will determine it. Examiner will never, in most cases, examiner will not give you the key factor per unit. For example, material kilogram will not be given to you. Labor hour may not be given to you. You are the one that will determine it. I will show you how to calculate it. However, you come here, you determine the key factor per unit. So you do your calculation, then you put it here. To now get the total key factor, you are supposed to multiply the required output. You multiply the output that you want to produce. You multiply units by the key factor per unit to get the total key factor. You then add up everything together. This will give you the total required key factor. Okay, then you less total available key factor. You less total available key factor. Whatever you have thereafter will then represent either a shortfall or a surplus. Okay, so this could be a shortfall. Let's manage our space, or a surplus. A shortfall will always be a negative. Surplus will be positive. All right. So like I said, once the required resources is more than the available resources, all right? When the required resources is more than the available resources, so that will give you, that means there is a constraint. That means there is a constraint. All right. Sorry, the reverse is the case here. Let me remove this. Okay. Shorts available. All right. So that is for, this is the table. Now, how do you then determine this key factor? This key factor per unit, how do you determine it? So to calculate the material kilogram, for example, if you want to determine material on the day of your exam, you are not going to be given material kilogram or labor hour. The examiner will give you material cost and then labor cost per unit. So you need to convert that to factor of production, the required factor of production. For example, if you want to determine material kilogram per unit, material kilogram per unit will be material cost. This is material cost divided by material per unit. So that will give you the material kilogram. Also, labor hour. Labor hour per unit will be calculated as labor cost divided by labor rates. All right. So this is how to calculate the material kilogram and labor hour per unit. So to get the material kilogram per unit, divide the material cost with the material per unit. All right. So it will give you the material kilogram. To get the labor hour, divide labor cost with the labor rate or wage rate, whatever it is, you get your labor hour. All right. So again, like I said, this is the table that you are going to use to confirm the insufficiency in the key factor. So that's step one. Step two says, calculate. Step two says, calculate contribution slash saving per key factor. All right, or per unit. Calculate contribution slash saving per unit. How do you determine contribution per unit? Okay, determine contribution slash saving per unit. for each of the product line. For each of the product line, you calculate contribution per unit or savings per unit. Savings per unit will only arise if it is optimal mix involving make or buy. In most cases, it will be contribution per unit. But if the question involves limiting factor involving make or buy, in that case, you are going to determine savings or deficit. Okay? Then step 3 says, confirm if management has placed priority or given minimum allocation to each of the product line. Oftentimes, management of a company may want to ensure that they produce uniform amounts across all the product line, and the balance available will then be allocated based on a kind of a specific based on specific requirements. All right. So step 3 says identify or confirm if management has placed priority or given minimum allocation to each of the product line. Management can say that let's produce 1,000 units across all the products. That's the what we are talking about. That means there's a minimum allocation for each of the product line. Then step 4 says you should determine contribution/savings per key factor. We determine contribution/savings per key factor. Again, there's a format that you can use for the purpose of doing that. But first thing first, in that step 3, I say you should calculate. Step 2, I say you should calculate contribution/savings per unit. How do you calculate contribution per unit? All right. Contribution per unit can be calculated in different ways. One, you can say contribution per unit is equal to selling price minus variable cost per unit. Or you can say contribution per unit equal to fixed cost per unit plus profits. That will give us contribution. All right. So depending on the information available, these are some of the ways in which we can calculate contribution margin. Now, step 4 says you should determine contribution/savings per key factor. How do you determine contribution/savings per key factor? And rank the results in a descending order. Let me look for space. Let me see if I can get a small, let me use this space. So to determine contribution or savings, contribution/savings per key factor, you use this format to do that. This is also one of the important steps. This is one of the important steps under optimal product mix, because this is what you are going to need. This is what we are going to use for the allocation of the resources. You are going to allocate out based on the ranking you have done in this particular step. So the first item will be contribution. First thing first, let's say we have 3 products. Products A, B, and C. Okay. Then the first item will be contribution or saving. Let's use contribution. So you then go and calculate contribution using the right formula for each of the products. Then the key factor per unit, which you have determined before in step 1. Key factor per unit, it could be labor hour per unit, it could be material kilogram per unit. Whatever it is, you put the key factor here. Let's say this is A, and then this is B. Then contribution per key factor. Per key factor. Because of space, let me use F. So this will be A divided by B. A divided by B will give you this. So the next thing you are going to do is to rank. You rank your results in a descending order. It's because of space. This is supposed to be contribution slash saving per key factor and then ranking. So you need to rank your results in a descending order. That is, according to the highest contribution slash saving per key factor. Whatever it is, let's say this is first, second, and third. This is how you are going to calculate your savings slash contribution per key factor. So it is this ranking that you are going to use for your allocation. Then step 6 says you should allocate the limited scarce resources among competing product line using the ranking in step 5. Okay, so how do you carry out? You need to prepare the allocation table. To prepare the allocation table, you are going to follow this format. This is the format you are going to use. There are about 8 columns to the format for the purpose of allocating the limited scarce resources. So the ranking you have done in step 5 will come as number 1 column. That's the first column. Then, based on the ranking, you are going to indicate the products. The unit demanded for each of the products, you indicate it. Then the key factor per unit that you have determined in step 1, you also indicate it in the column. Then you need to determine the total key factor. The total key factor will then be the unit of each product multiplied by the key factor per unit. So that will give you the total key factor allocated. In this case, when you are allocating, you have to take into consideration the total available resources because it's what you have available that you want to allocate out, not what you require. What you require, you don't have enough to produce it. Therefore, the little you have is what you want to produce. So that little that you have is what you want to allocate to each of the product line. And that's why you are using ranking to carry out the allocation because you want to maximize contribution or profit. Next column will then be to create cumulative allocation, starting from your first allocation. So you determine cumulative allocation. This cumulative allocation minus the resources available, which will give you the balance. Then you determine the optimal product mix. The optimal product mix is the unit that you want to produce. All right? The optimal product mix is the unit that you want to produce. So that's how you are going to do for all the product line based on the ranking. Then the final step, or step 7. Step 7 is to determine the optimal product mix. The optimal product mix is in this step 6. Whatever you have here in step 6 is what you are going to produce. However, in addition to your production mix in step 5, in step 6, if in the question you have minimum allocation, then that minimum allocation plus whatever you have in this table as your optimal mix, the two of them together is what will represent the production plan that will maximize contribution. Then finally, step 8 or step 7 is to now determine the profits or contribution achievable. You determine profit or contribution achievable. All right, so these are the 7 or 8 procedures that you need to carry out anytime you want to allocate limited scarce resources when there is a single constraint. All right. So let me just, as a recap, the first step is to identify the key limiting factor by comparing the required resources with the available resources, whether it will result in a shortfall or surplus to the organization. Step 2, you calculate contribution/saving per unit for each of the product line. Then step 3, you confirm if management has placed priority or given minimum allocation to each of the product line. If that is not available, then you move to step 4. Step 4 is to determine contribution/savings per key factor. All right, by dividing the contribution or saving with the key factor per unit, and then you rank the final result in a descending order. Then step 5, you prepare allocation table. Using this table, it's about 8 columns. This is the allocation table. All right. Then step 6 says you should determine or you identify the key, you identify the optimal production plan from the allocation table. So what you have in the last column of your allocation table will represent the optimal product mix. And I also said that if in the question you have been given minimum allocation, that means you are going to have 2 different kinds of units. The one you have determined in step 5, where you have this allocation table, then plus the minimum allocation. Then the final step is to determine the contribution or profits derivable from the allocation. So these are the procedures that you need to carry out in relation to optimal product mix. So if that is the case, let's have illustration. Before that, let me know if you have any question for me. All right. So let's have illustration. Like I said, we are going to have four different illustrations. We are going to solve a regular question. We are going to solve another one that involves minimum allocation. Then 3, we are going to have optimal mix involving make or buy. Then 4, you are going to have optimal mix involving a special order. So these are the 4 different ways in which examiner can test you under optimal product mix. So quickly, let's start. Let me see first. Let me see all the questions that we have here, Marcus. Okay. All right. So let's start with illustration number 1. Let's start with illustration number 1. We read out Amarachi Bottling Company Amarachi Bottling Company PLC produces 4 products, A, B, C, and D, with the following information. The personnel department has recently informed management that only 300,000 labor hours can be obtained in the labor market. Now, when you are given this kind of scenario, one thing should call your mind. Examiner has told you that the personnel department has recently informed management that only 300,000 labor hours can be obtained in the labor market. You are required to determine the optimal product mix, showing the allocation of resources and calculate the maximum profit derivable from your allocations. So, examiner has given us a clue that in this organization, labor hour is the constraint, because we are told that 300,000 labor hours can be obtained in the labor market. Therefore, what this organization, Amarachi Bottling Company PLC, has is 300,000 labor hours. So, in that case, examiner is now asking you to determine optimal product mix for the purpose of determining the production plan that will maximize profits. Therefore, what are you supposed to do? It's very straightforward and simple. Any question on optimal product mix is always very straightforward. So you have responsibility to be able to master those 7 steps. Okay, no matter how big is the question, it's the same procedures. So let's follow those 7 procedures to solve this particular question. So you want to determine optimal product mix that will maximize contribution or profit for Amarachi Botany Company. Let's see how we are going to solve this. Remember, step 1 is to identify the key limiting factor. How do you identify the key limiting factor? You need to compare the required resources with the available resources. In this case, the key factor will be labor hour, because examiner has given us a clue that labor hour is limited to 300,000. So this is the available labor hour. So we need to compare with the required labor hour. For us to be able to produce all these units, for us to be able to produce the unit to maximize contribution, for us to be able to produce all the required units to take advantage of market condition, then you need to determine the labor hours that will be required to produce 20,000 of A, 16,000 units of B, 24,000 units of C, 10,000 units of D. So if the total required labor hour is more than the available hours of 300,000, it means that there is a constraint. We then move to step 2. So because of time, let me stop sharing this and move to the working notes. So we want to determine optimal product mix for Amarachi Bottling Company. This is page 40, illustration number 1. Okay. So the first thing you are going to do, of course, this is solution. So illustration 1, page 40. The name of the company is Amarachi Bottling Company Limited. So examiner is asking us to determine the optimal product mix. So I can say determination of optimal product mix, OPM, optimal product mix. To do this, we are going to carry out 7 different procedures. Step 1, you identify the key limiting factor by comparing the required resources with the available resources, whether it will result in a shortfall or surplus to the organization. So first step is to confirm the insufficiency in labor hour. Examiner has mentioned to us that labor hour is limited to 300,000. That means labor hour is the key factor. So I will then come here, confirmation of insufficiency in labor hour. In labor hours, because we have been told that labor hour is limited to 300,000. In this question, we have 4 different products, products A, B, C, and D. Okay, so I would then say the first column will be products, followed by the budgeted units, or simply put, units. Then we have labor hour. Labor hour is the key factor. So we need to determine labor hour per unit. Then we determine total labor hour. We have product A, B, C, and D. Then we are going to have total required labor hours. Then compare with the total available labor hours. Okay? Let me complete my table. We want to know whether it will result in a shortfall or a surplus. Right. Okay. So what are the units? Give it to me. What are the total units for product A? Budgeted units or budgeted sales? Are you there? For product A, we have 20,000 units. 16,000 for B.
24,000.
24,000.
24,000 for C.
10,000 for
10,000.
B.
And then 10,000 for D. Now, like I mentioned earlier when I was explaining the concept, the key factor per unit will not be given to you in most cases. You are the one that will determine it. Therefore, how do you calculate the key factor per unit? Because examiner has told us in the question that labor hour is limited to 300,000. Therefore, you need to determine labor hour per unit. And that labor hour per unit is not given in the question. So we are going to use the labor cost and the labor rate to be able to determine the labor hour. Therefore, note, labor hour is equal to labor cost per unit divided by labor rate. So in this case, I will then go to the question for product A. Labor cost is 6 naira per unit. Labor cost per unit is 6 naira. 8 naira for B, 7 naira for C, 3 naira for D. So 6873. 6873. Then divided by, I will then go back to the question. What is the labor rate given to me? According to the question, labor rate per unit is 1 naira, 2 naira, 1 naira 5 kobo, and then 0.5 kobo for product A, B, C, and D respectively. So 1, 2, this one is divided by 1. This one is divided by 2. This is divided by 1.5. And this is divided by 0.05. 0.5. 6 divided by 1 will give us 6 hours.
6.
This one will be 4 hours. 7 divided by 1.5. What do you have there?
4.67.
So 4.67. So let's say rounding 5 hours. All right. Then 3 divided by 0.2 will give us 6 hours.
6.
So to now get the total hours, you multiply the units with the labor hour per unit. 20,000 multiplied by 6 will give us 120,000 hours. 16,000 multiplied by 4, That should be 64,000.
64,000.
Yeah. So 24,000 multiplied by 5. That should be 120,000, I think. 24 multiplied by 5. Yeah, that's 120. 10,000 multiplied by 6 will give us 60,000.
50,000. Okay.
Then we add up everything. This will give us 364,000. So we are told in the question that labor hours is limited to 300,000. That's the available labor hours. So you then call me 300,000 that is available. The difference is 64,000. All right. So because for the company to be able to take advantage of market condition, for the company to be able to satisfy customer demand, 364,000 labor hours are required. But the company does not have 364,000. The company only has 300,000 labor hours. You cannot give what you don't have. What you have available for production is 300,000 labor hours. That's what you are going to use for your production. So because the required resources is more than the available resources, that means this 64,000 is a shortfall. That's a shortfall. That's a constraint. All right. Now, you will see that when I was allocating for product C, I restricted I mean, 7 divided by 1.5 is 4 point something something, and I now rounded it to 5 hours. So if you use what you have in your calculator, it's still the same thing. For simplicity, that's why I rounded it to 5. Okay, move on from here. So this is for step 1. Now that we have confirmed that the labor hours of 300,000 is truly not sufficient to produce, but there's nothing you can do. That's the total that you have, because you cannot give what you don't have. So at this point, I will then move to step 2. Step 2 says I should calculate contribution per unit. Savings will not arise because this question does not relate to make or buy. It is only when you have optimal mix involving make or buy that savings will arise. In most cases, it will be contribution. Therefore, step 2 says I should calculate contribution per unit. So I would then say contribution per unit. How do I calculate contribution per unit? The information I have in the question will tell me how to calculate the contribution per unit. So we need to go back to the question and identify, am I given sales value? Am I given selling price? If I'm given selling price, then contribution will be selling price minus variable cost per unit. If I'm not given selling price, I will also check in case I'm given profit per unit and fixed cost per unit in the question. So you must know what to do at the right time. So in this particular question, we don't have selling price, but we are given fixed cost and profit per unit. That's what we are going to use to calculate our contribution. So in this case, our own contribution per unit will be fixed cost plus profit. Okay, so you then do for each of the products. For products A, B, C, and D. So fixed costs per unit of product A is what? What's the fixed cost of product A per unit?
1,
B,
2,
C,
3,
3.
and 1.
and 1. Then the profits per unit.
20.
20, B,
25.
C,
21.
and D.
15.
All right. So we then add it up to get the contribution per units. So this will give me contribution per unit for each product. Here will be 21, 27, 24, then 16. Now that we have contribution per unit, step 3 says we should confirm if management has placed priority or given minimum allocation to each of the product line. In the question, we are not told to give minimum allocation to each product line. Therefore, you are going to skip or ignore the step 3. You move to the next step, which is step 4. Step 4 says you should determine contribution per key factor. So, step 3, contribution per the key factor, we know it, which is labor hour. And ranking. Okay, so we have products A, B, C, and D. Optimal mix question is always very interesting if you understand the formats, the procedures. So the first item here will be the contribution. Contribution for A is 21 naira. B is 27, 24, then 16. Then we have labor hour, which is key factor per unit. Labor hour per unit. Let's say this is A, this is B. Labor hour per unit. Here is 6. I think the other one is 4. Yes, 6, 4, 5, 6. 6, 4, 5, 6. The labor hour per unit is the one we calculated in step 1. All right, so all these items you have here, they are your key factor per unit. Therefore, you then determine the contribution per key factor. Contribution per labor hour. That is A divided by B. 21 divided by 6. What do you have?
3.5.
3 point what?
5.
27 divided by 4.
6.75.
6.75. 24 divided by 5.
4.8.
4.8. 16 divided by 6.
2.67.
2.67. Then the next thing we are going to do is to rank our results in a descending order. Descending order simply means according to the highest contribution per labor hour. So I will then come here, ranking.
BCAD.
So based on the ranking, the first one is B. B
B.
is first,
C.
followed by C,
A.
then A,
D.
then D is the last one based on the ranking. So this is how to determine key contribution / saving per key factor, right? Then step 4 now is to prepare allocation table. I would then say allocation of what do you want to allocate out? You want to
Labor hour.
allocate the available resources. The labor hour of 300,000 is what you want to allocate out. Therefore, we then say allocation of 300,000 labor hours. Okay. So to do this, you are going to create about 8 columns. The first column is the ranking. Next is the products that you have ranked. Next is the units demanded. Then you are going to have labor hour per unit. You have total labor hour. You have cumulative allocation. You have balance. Then we have optimal product mix. So there are 4 products. That means we have 4 different ranking. 2, 3, 4. Pay attention to our allocation table. Now, based on the products, based on the step 3, based on our ranking, the first product is B, followed by C, A, and then D. Okay. Now, how many units do we have for product B? What are the
16,000.
total units of product B? Product B is 16,000 units. Product C,
24,000.
product A,
20,000.
and then 10,000 for product D. So these are the units, budgeted units. So the key factor per unit that we have determined for B, labor hours for B is 4.
4.
4 hours. For C, 5 hours. For A, 6 hours, then 6 hours for D. Now, pay attention. We want to allocate 300,000 labor hours. At all time when you are doing your allocation, you have to bear in mind that you cannot give what you don't have. The maximum you have available is 300,000 labor hours, and that's what you want to allocate. Now, when you are carrying out your allocation, you have to do this on the basis of the ranking. You are allocating the limited scarce resources based on the ranking that you have done. So according to the ranking, the highest ranking is product B. Therefore, we want to allocate out of the 300,000, how many labor hours will be required to produce product B? So 16,000 multiplied by 4 will give us 64,000. So that means out of the 300,000 labor hours, we have allocated 64,000 to product B. So cumulative, 64,000 is the first one. Therefore, cumulative for the first one will be 64,000. Balance, 300,000 minus 64,000. That will give us 236, right? So the balance of the labor hours after allocation to B is 236,000. Therefore, how many units of product B are we going to produce to maximize contribution? Since there is no restriction for product B, that means we are going to produce the entire 16,000. Because to produce this 16,000 units for product B, it requires 64,000 labor hours. We have allocated 64,000 labor hours. That means we don't have any constraint on product B, and that's why we are going to produce the entire 16,000 units. I'm done with product B. I will then move to the next highest ranking. The next highest ranking is product C. 24,000 multiplied by 5 will give us 120,000 naira. Sorry, 120,000 labor hours. I have a balance of 236,000 labor hours. 236,000 can accommodate 120,000. Therefore, I will then come here. I will allocate 120,000 to product C. To get the cumulative, 120,000 plus initial 64,000, that's 184. To get the balance after allocation to C, 184,000 minus 300,000, that will give us 116,000. Now, for product C, again, we don't have a constraint because 120,000 hours is required to produce 24,000 units. And we have allocated 120,000 to product C. That means we are going to produce 24,000. No constraint for C. We then move to the next one. The next highest ranking is product A. 20,000 multiplied by 6 will give us 120,000 labor hours. We don't have 120,000 labor hours available because out of the 300,000, we have allocated 184,000. We are left with 116,000. Therefore, the balance of 116,000 is what you are going to allocate to product A. You don't have 120,000. What you have available is 116,000.
Sir, sorry. Please, how did we get the 116,000?
184 minus 300,000.
Okay. So we still minus it from 300,000. I thought
The
we were going
total
to
you have
deduct
available,
the balance.
the total you have available is 300,000. You have allocated 184. 184 minus 300 will give you balance of 116. So cumulative 116,000 hours plus 184,000 hours will give us 300,000. 300,000 minus 300,000 labor hours available. You have a balance of 0. Therefore, how many units of product A are we going to produce? For product A, we don't have sufficient. We need 120,000 labor hours to produce. We don't have 120,000 hours. We only have 116,000, and that's what we allocated to A.
Excuse me, sir. Excuse me, boss. Please,
You
how
guys
did
should
you get
stop disrupting me.
Sorry,
Excuse me.
sorry,
Stop
boss. I
disrupting
just
me. If
wanted
you
to
want to
ask.
ask me a question, raise your hand.
Okay. Okay. I want to ask a question,
Ask your
please.
question.
Okay, so I wanted to ask,
Talk to me.
I wanted to ask how you got the 300K. Is it the 300K of the labor hour that you brought into the cumulative or product 3? I mean, product A.
You know we are doing the cumulative. We started with product B. We allocated 64,000. That formed the first cumulative hour for products after allocating to product B. The next
Yes,
one
I
we
understood
allocated
that.
120,000. So you had 120,000 to initial 64,000. That's what produced the 184,000.
Yes.
The third one, which is product C, product A, you allocated 116,000 hours plus the cumulative of 184. That's what gave us the 300,000.
Yeah.
Do you get?
Yes, yes, yes.
Is it clear?
Yes, 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 it is.
Okay then. So you then go ahead. You need to know how many units are you going to produce for product A. Like I said, product A requires 120,000 labor hours. But because you don't have 120,000, you restricted your allocation to A to 116,000 because that's what you have available. Therefore, to then determine the units to produce for product A, it will be the total allocated hours of 116,000 divided by hour per unit of 6. So what do we have here? 116,000 divided by 6. What do we have?
19,333.3.
So 19,000 333 units. So nothing will go to product D because we don't have sufficient resources to produce D. Please let me know if you have any question on this table before we proceed to the next step. Is there anything
sir,
that is not clear to you? Yes, talk to me.
Sir, this
Talk.
19.333, if you times it with 6, it will give you 1116. So the difference, are we not supposed to approximate to 4 so that it will give you 1116,004?
You can't approximate to 4. What the number you have there is 0.333. 3 is not up to 5, so you cannot approximate. Just leave it as it is. All right? You don't need to approximate in this area, so because fractional output can be undertaken. All right? So no need to approximate. Is it clear, Meshach?
Okay. Why I'm asking,
All right.
because if you times it, it will give you this.
You don't, that doesn't matter. That does not matter. I understand your point. If you multiply with 6, it will not give you 116 because your answer is 19,333.33333. So that 0.3 is not, that 0.3 is not up to 5, so you cannot round it. That's what I'm saying. You can't round it to 19,334. So just leave it as it is. The worst case you can do is to just say 19,333.33. That's okay. But leave it as it is. Then step 5 is to determine optimal product mix. So I would then say optimal product mix or production plan. We want to determine production plan that will maximize contribution. So to do this, since we have done only one allocation, so no need to worry yourself. So I will just come here. I will have the products, then allocation. To maximize contribution for product A, B, and C, you are not going to produce anything for D because you don't have sufficient resources to produce for D. So for product A, we are producing 19,333. 19,333. For B, we are producing 16,000 units. Then for C, we are producing 24,000. Therefore, these are the units. These are the units that will maximize contribution and profit for the organization. These are the units that will maximize contribution as well as a profit for Amarachi Bottling Company Limited. Okay. Finally, step 6, examiner is asking us to determine the profit derivable from the allocation. All right. Calculate the maximum profit derivable from your allocation. So step 6, I would then say income statement. I want to prepare income statements. So we do for product A, product B, product C, then total for the company as a whole. So production plan. The production plan that will maximize contribution for A is 19,333. B is 16,000 units. Then 24,000 units for C. So these are the units that will maximize contribution for Amarachi Bottling Company. Then In the question, examiner has given us, instead of me to use contribution, I will not use contribution because I already have profit per unit. Therefore, I will then come here, I will say profits per unit. Profit of product A, I think is 20. For B, profit of B is 25. So 25, 21, 15. 25, 21, that's it. I will then multiply. Let's say this is A, this is B. So I will multiply to get the total profits. So total profits. So this will be A multiplied by B. So what do we have here? 19,333 multiplied by 20.
368. 386,660 naira.
386.
86. 660 naira.
Okay. 660. Then for product B, 16,000 multiplied by 25.
400,000.
400,000. For product C,
504,000.
504,000.
504,000. Add it up. Add the three of them together to get the total.
$1,290,000.
Yep.
660.
290,660. So this is the total profits that the company will be able to earn. So that's that. You can see it's very interesting. Let's have another illustration. Before we go to another question, let me know. Do you have any concern? Is there anything that is doing you why in this question that we just solved?
Yeah. Yeah, sir, I have a question.
Talk to me.
My major issue here is this key unit. That's the key factor where we have to
Okay.
do the labor cost per unit divided by labor rate. Is it when it
Okay.
is given in kg we do that? Because at times you see it is given in kg, so that's when, or it is given in naira. So it's kind of trickish when to divide. Please, can you explain more?
Since you already have the formats and what you should do when you see it in the question, when I was explaining the concepts, I mentioned to you how to determine key factor per unit. I said in the question, examiner, in most cases, examiner will not give you material kilogram per unit. Labor hour per unit will not be given to you. You are the one that will determine it. You are going to determine it yourself. So how do you determine material kilogram per unit? And I said material kilogram is material cost divided by material per unit. How do you determine labor hour per unit? Labor hour per unit is equal to labor cost divided by labor rate. That's what you need to do. It's not more than that. So in the question, examiner will not tell you what to do. It is implied that you know what you are doing. And that's why I took my time to be giving you those kind of formula, what you should do to convert material cost to material kilogram, labor cost to labor hour.
Yeah, my question is when to convert. Is it because there are some questions they will put it in naira?
That's what I'm saying. If it is, you don't use naira, it has to be kilogram, it has to be labor hour. That's what we are saying now. This labor cost is what that will be given to you. Material cost is what that will be given to you. When you say cost is in naira now. So you are the one that will now convert it to material kilogram and labor hour. Don't worry. As you proceed, you are going to see several examples. In fact, even when we get to linear programming, it's still the same thing. All right?
Okay, sir.
Yeah. So we are going to have another example now. You see how we are going to treat it.
Hello, sir.
Yes, talk to me.
Step 3 that we omitted. How are we going to do it?
Ye-
As in, say, assuming we were asked to calculate we were asked to calculate the minimum allocation.
We are given minimum allocation. So in that case, let's do a question that involves minimum allocation. Let me stop sharing this. So that you'll be able to see how to treat the question when you are given minimum allocation. Let me see. Okay. Yeah. Let's solve this illustration number 2, panorama. I need one of you to read for us. Panorama. Who is helping us? Quickly, we have about 30 minutes more. Yes? Who is helping us to read?
Okay. Panorama Manufacturing Company Limited is currently preparing its budget for the year ending 31 December 2014. The company manufactures and sells 3 products: Alpha, Beta, and Sigma. The unit selling price and cost structure of each product is budgeted as follows in the schedule. Direct labor rate is budgeted at 6 naira per hour, and fixed cost at 1.3 million per annum. The company has a maximum production capacity of 228,000 direct labor hours. A meeting of the board of directors has been convened to discuss the budget and to resolve the problem as to the quantity of each product which should be made and sold. The sales director presented the results of a recent market survey, which revealed that the market demand for the company's product will be as follows in the schedule. Products. The production director proposes that since SEMA only contributes 12 naira per unit, the product should no longer be produced, and the surplus capacity should then be transferred to produce additional quantity of alpha and beta. The sales director does not agree with the proposal. SEMA is considering necessary to complement the product range and to maintain customer goodwill. If SEMA is not offered, the sales director believes sales of alpha and beta will be seriously affected. After further discussion, the board decided that a minimum of 1,000 units of each product should be produced. The remaining production capacity will then be allocated so as to achieve the maximum profit possible required. Prepare a budget statement which clearly shows the maximum profit which will be achieved in the year ending 31 December 2014.
Yeah, thank you very much. Yes, that is the requirement. Examiner is asking you to prepare a budget which clearly shows the maximum profit which could be achieved in the year ending 31st December 2014. So you want to determine, examiner is asking you to prepare budget statement, that is income statement, that will enable the company to maximize profits. When you look at this question, when you are reading, after the first table, the examiner mentioned that the company has a maximum production capacity of 228,000 direct labor hours. So this is a clue. In all cases, examiner will always be giving a clue in the question. So this simply means that direct labor hour is the key limiting factor, because you are told that the maximum production capacity of 228,000 naira is what the company has. 228,000 direct labor hours is what the company has. Therefore, and then also in the question, you are told, because there is a conflict in this company between the between the production director and also marketing director. The production director proposes that because SEMA contributes only 12 naira per unit, then the company should discontinue producing SEMA, and the resources of SEMA should then be used, should be transferred to produce alpha and beta. But the sales director has a different opinion, because the sales director is saying that SEMA is necessary to complement the product range and to maintain customer goodwill. Okay, this is what we discussed under deleting of a segment. All right. Then we are now told that after further discussion, the board decided that a minimum of 10,000 units of each product should be produced. That means you have been given minimum allocation. Where there is minimum allocation, how do you treat it? That's what we want to do. So I will stop sharing this and move to the working note. So in this case, since there is minimum allocation, we are going to complete the 7 procedures, the 7 or 8 procedure for the purpose of our allocation. So this is solution. So illustration number 2. Still on page 40, I think. Let me confirm the page. Yes, page 40. All right. So the name of the company is Panorama Limited. So I would then say determination of optimal product mix. Okay. We want to determine the optimal production plan that will maximize contribution for Panorama Limited. So the first step says you should confirm the insufficiency in labor hour. Examiner has given us a clue in the question that we have 228,000 direct labor hours. That's the available labor hours. I would then say confirmation of the insufficiency in direct labor hours. Labor hour is limited to 228,000 hours. So create a column for products, the units to be produced and sold. Then we have labor hour per unit. Then we have total labor hour. We have 3 different types of products: alpha, beta, and then SEMA. So we are going to have total required direct labor hours. We compare this with the total available labor hours. The total available labor hours is 228,000. So what are the units for each product? Give me the number of units.
24,000.
24,000.
12,000.
Next,
10,000.
12,000.
and then
60,000.
60,000. Okay, then. So let's determine labor hour per unit. According to the question, when you go back to the table given to you, you are given labor cost of 24 naira for alpha, 48 naira for beta, and then 32 naira for sigma. After the table, you are already told that direct labor rate is budgeted at 6 naira per hour. Therefore, to get the labor hour per unit, it will be labor cost divided by labor rate.
Yes, sir.
So the first one, for alpha, labor cost is 24 naira. So this will be 24 naira divided by labor rate of 6 naira. So this will give you 4 hours. For beta, we have 48 naira. 48 naira divided by 6 naira will give us, that should be 8 hours. Okay, this should be 8 hours. Then for SEMA has 32, is it 32
6.
naira?
6.
6.
6 naira, okay, 6 naira divided by 6. So here will be 6 divided by 6 naira. That will give us 1 hour. To now get the total labor hour, you are supposed to multiply 24,000 by 4. That will give us what?
96.
6,000 hours. 12,000 multiplied by 8.
96,000.
96,000. 60,000 multiplied by 1.
60,000.
That's 60,000.
60,000. Therefore, add it up. What do you have there?
252,000.
252,000. So, for this company to be able to maximize contribution towards profits, 252,000 direct labor hours are required. But the company is facing challenges. The company only has 228,000 direct labor hours. Therefore, your plan would then be to allocate the limited resources that you have. What's the difference? The difference
24,000.
is 24,000. All right. So that means there is a shortfall because the company requires 252,000 to maximize contribution, but the company only has 228. So there's a shortfall of 24,000. So that's step one. That means this confirms that there is insufficiency in direct labor hours. We then move to step two. Step two says we should calculate contribution per unit. So I would then say contribution per unit. How do I calculate the contribution per unit in the question? So we need to go back. In this
Selling
question,
price.
we are given
Minus variable
you are
cost.
given selling price, you are also given variable cost. Therefore, our contribution per unit will be calculated as selling price minus variable cost per unit. Okay. So we do for alpha, beta, and then sigma. How much is selling price of alpha?
100.
100.
100. Beta,
124.
And then CIMA,
32.
32. We then deduct variable cost. How much is variable cost of alpha?
60.
Okay.
60,000.
What about beta?
60.
60,000.
Then for CIMA,
20.
20,000.
20 naira per unit. Okay. So the difference between the two will then give us the contribution per unit. So here will be 40, 64,
64.
and then 12 naira. So when you look at this 12 naira for CIMA, which confirm the arguments in the question, because the production director is saying that since CIMA only contributed 12 naira, okay, so they should discontinue producing CIMA. So that's how they got the 12 naira. So step 3 says you should confirm or check if management has placed priority or given minimum allocation. So in the question, we have been given minimum allocation of 10,000 units across board. So I would then say minimum allocation. So the products, the minimum allocation, labor hour per unit, then total labor hour required to produce the minimum allocation. So we have alpha, beta, and then sigma. Okay, so we have been required to produce 10,000 units minimum for each product. This will resolve the conflict between the two directors, between production director, and then marketing director or sales director. Epele, it is well. So labor hour per unit, we have calculated in step 1. For alpha, labor hour per unit is 4. So we have 481. 481. So 10,000 multiplied by 4 will give us 40,000 hours. 80,000 hours, 10,000 hours. When you add it up, that's 130,000 hours. Anytime there's minimum allocation, what we are trying to do in this step 3 is to determine how many hours will be required to produce the minimum allocation so that the balance that you have is what you are going to reallocate out. So this is total minimum labor hours required to produce the 10,000 units. So the total, you then compare this with the total available labor hour, which is 228,000. So the difference is what we are going to allocate out. What's that difference? I think that should be 98. Confirm. What's the difference? Balance.
98
Available.
confirmed.
So the difference
98.
is
98,000.
98,000. So it is this 98,000 you are going to allocate out again. All right. So that would then take us to step 4. Step 4 says you should calculate contribution per labor hour, that is contribution / saving per key factor. So I would then say contribution per labor hours and ranking. So we have alpha, beta, and then sigma. So the first item will be contribution. Let's say this is A. We calculated contribution to be 40, 64, 12. 40, 64 naira, 12 naira. Then labor hour per unit, which is B. We calculated 481. Here is 481. Therefore, contribution per labor hour, that is A divided by B. Forty divided by 4 will give us 10. 64 divided by 8 will give us 8. 12 divided by 1 will give us 12. The next one is ranking in a descending order. Based on our ranking, sigma is first, followed by alpha, then beta is third. All right, then step 5, allocation. Pay attention here, please. Please, what you are allocating is the balance of 98,000. You are allocating this balance of 98,000. You are not allocating 228 again, because out of the 228, you have allocated out 130,000 hours. So you are left with 98,000. It is that balance of 98,000 that you want to allocate out. So allocation of balance of 98,000 labor hour. You have to shine your eye. So the first item is ranking. Units. Key factor per unit, that is labor. Sorry, product before units. Products, units, labor hour per unit. Total labor hour. Cumulative, balance, then optimal product mix. The first ranking, second and third ranking. We can see optimal product mix is very interesting. Just understand the format, the procedures, and you are good to go. Okay. Let me complete my table. I always like to do the right thing. Don't say because you are in a hurry, you read one side of your table and you ignore the other side. If you meet with a very difficult examiner or person that will mark your scripts, will tell you that that's not a group presentation. You can't leave one side of the table because you are so much in a hurry and leave the other side. You have to, table is a table. You have to complete it. Now, based on our ranking, highest is product C, followed by A. So that's CAB. C, A, B. How many units of units? How many units of SEMA are we going to produce? Yes, Lekon, talk to me quickly.
Yes, sir. Please, why are we not allocating the full? Because in the first question, we allocate the full 300,000 labor cost, labor hours. But here we are using 98,000.
Okay. Examiner is telling you that you have 228,000 labor hours available. And we have confirmed that it's truly, that 28,000 labor hours is not sufficient, because for the companies to be able to maximize contribution, 252,000 labor hours are required. However, you have been given minimum allocation of 10,000 units. The 10,000 units you want to produce, you can't just produce. People will produce that 10,000 units for each of the products. They are going to spend hours to produce it. Therefore, how many hours will be required to produce 10,000 units for Alpha, Beta, and Sigma? We have calculated total minimum hours required to be 130,000 hours. So out of the 228,000 hours, you have allocated 130,000 hours to produce 10,000 units for each of the products. So you have a balance of 98,000. So it is that 98,000 balance you are going to allocate out again, not the 228. Is it clear, Lekon?
Yes, sir. Thank you, sir.
All right. So how many units of, you have to pay attention here. In this step 5, we want to know how many units can we produce again? We have produced 10,000 units for each of the products. So this 98,000, oh, sorry, this one's supposed to be 98,000. I wrote just 98. 98,000. So this 98,000 direct labor hours, how many units of products Sigma, Alpha, and Beta are we going to produce with it? That's what we want to do now. Now, when you look at the question for Sigma, out of 60,000 units, we have produced 10,000 units minimum allocation. That means we have a balance of 50,000 units. So you then come here, 50,000. Also, for Alpha, Alpha requires 24,000 units. You have produced a minimum 10,000 units. So you are left with 14,000. Beta requires 12,000 units. You have produced 10,000 units out of the 12,000. So you are left with 2,000 units. Therefore, what are the hours per unit? 481. For Sigma, 1 hour is required. For Alpha, 4. Then 8 for Beta. So you are going to start with Sigma. 50,000 multiplied by 1 will give us 50,000 hours. 50,000 hours is within 98,000 hours. Therefore, we are going to allocate additional 50,000 hours for Sigma. Cumulative will be 50,000 being the first one. 50,000 minus 98,000 will give us a balance of 48,000. Therefore, out of these 50,000 units, how much are we going to produce? There is no restriction for Sigma. Therefore, sorry, this is not CAB. It's Sigma Alpha. This is Sigma Alpha and then Beta. Okay, so we are going to produce 50,000 units for Sigma. because there's no restriction. You require to produce the 50,000 units, you require 50,000 labor hours, and you have allocated the 50,000 labor hours. That means there's no restriction. That's why we are producing OPM, optimal product mix. We are producing 50,000 units. Now, for alpha, 14,000 units multiplied by 4 hours. What do we have there? 14,000
56.
multiplied by 4. That's 56,000. Do you have 56,000 left?
No.
So out of 98,000 labor hours, we have allocated 50,000. We have a balance of 40,000. However, Alpha is asking for 56,000 hours. We don't have 56,000 hours. We only have 48,000 hours. Therefore, you have to restrict to what you have because you cannot give what you don't have. So cumulative, 48,000 plus 50 will give us 98. After allocation to alpha, 98,000 minus 98,000 will give us a balance of 0. Therefore, how many units of alpha, how many units out of the 14,000 are we going to produce? So I can say alpha.
That's 1, 2.
Alpha. You say it's what?
1, 2.
1, 2. So you can say 48,000 divided by 4. That will give us 12,000. So out of the 14,000, we can only produce 12,000 units of alpha. Nothing will go to beta because you don't have sufficient to do that. So step 6 says you should determine the optimal production plan. Step 6, optimal product mix or production plan that will maximize contribution. You can call it optimal production mix, optimal product mix or production plan. So because anytime there is minimum allocation, that means you are going to have two different allocation. So our format will be slightly different. So we are going to do for alpha, beta, and then sigma. So we have two different allocation. The first one is minimum allocation. So we have given minimum allocation of 10,000 units for each product. And we have allocated additional for sigma 50,000, for alpha 12,000. Additional allocation. For alpha is 12,000. Beta, nothing. Sigma, 50,000. You then add it up to get the optimal production plan. So optimal, or simply say production plan. So this is the production plan that will maximize contribution or profits. So for alpha, that's 22,000. 10,000 for beta, 60,000 for sigma. Once you get to this point, that's all. You are good to go. There's assurance that You have covered almost 90% or 95%. The last step is to then determine your profits derivable. That is, you prepare income statement. So you have for alpha, beta, and then sigma. Total for the company as a whole. Then the production plan, which represent the units that will maximize profits. For Panorama, we are producing 22,000 of alpha, 10,000 of beta, then 60,000 of sigma. Then we have contribution. In this question, we don't have profit, so you have contribution. So we have calculated contribution per unit for alpha to be 40, 64 for beta, then 12 for sigma. 40, 64, 12. 40, 64 naira, 12 naira. You then multiply. You multiply to get the total contribution. Total contribution, which is A multiplied by B. Give it to me. This should be 880.
80,000.
Okay. Next,
64.
that's 640. Next, this should be 720. Please confirm.
It's
Okay.
correct.
All right then. So add it up. Add the contribution.
2,240,000.
2,240,000. That represents the total contribution. So examiner wants you to determine the profits. The maximum examiner wants you to prepare a budget statement which clearly shows the maximum profits which could be achieved, okay, in the year ending 31st December 2014. So you want to determine profits. To determine profits, profit is contribution less fixed cost. So when you go back to the question, we are given after the first table, you are told that fixed cost at 1,300,000 naira per annum. So there's a fixed cost of 1,300,000. So I would then say fixed cost. You don't need to apportion fixed cost to anyone, just ignore. We don't need anything like apportionment here. So just take the entire fixed cost to the company as a whole, which is 1,300,000. Therefore, what's the difference? That should give us 940,000. Am I correct?
Yes, sir.
So this represents the profits. That's the net profits. That's end of the question. It's as simple as that. It's as simple as that. Okay, so let me know if you have any question for me. So today we have solved question under normal scenario, which is very straightforward. The second one we solved is where there is minimum allocation. How do you treat optimal product mix when there is minimum allocation? That is essence of this question. In our next class, we are going to solve questions that involve make or buy. That is limiting factor involving make or buy. Then 2, We also solve limiting factor involving special order. Each of them have a special way of treating them. All right. So next week, by the grace of God, we are going to do that together. So finally, let me know if you have any question for me so that we can close the class. This is the what we can do today. Yes, Ramon, talk to me quickly.
Yes, sir. Sorry, I joined the class late, but I can see that you are using the procedure from our booklet that you are showing us how we can follow these
I don't know whether it's my line. I'm struggling to, I can't hear you.
steps. But
Take
as
it
I'm looking at
again,
the steps, it's
Ramon.
like yeah. Okay, I said from the booklet, I can see that you are following the procedure in calculating this in solving the question. But from the booklet, the procedure seems to be confusing because I don't know. It's like it's confusing
Which
from what me I'm
booklet?
seeing here. Yes. From the this thing you gave us.
The study material.
The study material, yes. So I don't know if you give is
In
you
your
give
study material, you have next step. You have, hold on. In your
you
study
have the
material, you
seven,
have next steps, right?
yes, we have 7 steps.
So I
And
only
I think that's
compressed
just that.
it. In that part, are you done talking, Ramon?
Yes, sir.
Ramon? So
I'm done.
in your learning material for PM, you have next steps. That next steps
Yes.
is what I compressed to 7. It's still the same thing. What's the first step you have there? Talk to me, Raman.
Identify the key limiting factor.
So
That's the
that's the
first step.
first thing we did here, Abi.
Yes.
So what's the second step?
Determine contribution, savings or relevant cost per unit for the product
So that's what we
lines.
did in this. That's what we did also, Abi.
Yes.
Oh yeah, now. Then step
Yes.
3. What do you have at step 3?
Determine key factor per unit for the product line, if not given.
Okay. So that's what we did. That's what we did in step 4 here. That's what we did in step 4. So I've reframed it. What I've given you is what you should do. What I have, the way I've solved it now that is the order you should follow.
Okay, that's
Next
what's
one.
confusing me because I'm saying that. Okay, number 4, you say calculate contribution, savings or relevant cost per key factor. This
So
can be
that's what
determined by dividing step 2 with step 3.
so that's what you have here in step 4. No
Okay.
be so. Then step 5 says you should rank, Abi.
Rank the contribution per
So
savings.
I've
Yeah.
matched step 4 and 5 that you have in the material. I've matched it to step. That's what you have in step 4 only. This is the ranking you have here. Next.
Ascertain if management place priority or has given minimum allocation for each product line.
So that's what we did in step 3. Do you get?
So why are we missing
So
the
what you
steps
are
in
not.
your
So that's what I just told you. Follow the way I've solved it now. The way
okay.
I've solved it is the most appropriate. Do you get whether if you
Okay.
follow the one you have in the book, it's still the same thing. Anyone that is more convenient for you is what you should do. All right. So there's no issue in the two. Whether you follow the one you have in the
Okay, sir.
book or you follow the one I just solved, it's still the same thing you are going to get.
All right, sir.
It's just a matter of approach. All right. Good. Yes.
Okay, sir.
Any other question so that we can close the class? Any question for me? Okay then. So in the absence of no further question, this is where we are going to call it a day. In our next class, by the grace of God, we are going to, hopefully, we are going to complete this topic by solving two more additional scenarios. One where we have make or buy, and then the last one where we have special order. Once we are done with that, then we then move to our next topic, which is going to be linear programming. For linear programming, we're also going to spend two periods for us to be able to do justice to the topic. And yes, in the absence of no further question, I want to say thank you to every one of you. We'll see you again by the grace of God next week, Friday, when we shall continue the topic. However, please, I beg of you, time is going. Time and time wait for nobody. We are getting closer to the D-Day. For each day that pass, please, I want you guys to get serious. This is the time for you to double your effort. Between now and when you are going to have your exam, you need to double your effort. If you have been reading for 2 hours per day, you need to double it to 4 hours. Create time for your studying. No matter how busy, you don't have any excuse to say, okay, it's because of work. I'm busy, I'm this, I'm that. Forget about that. You are not the only one in that shoe. Some people, some students are even busier than you think you are, and they still create time for them to study. You are the one paying for the lecture fee. You are the one paying for the exam and exemption. You are the one that needs the qualification, and you have to give it what it will take you to achieve that excellence. You are the one that want to achieve, you want to earn the ICAN certificate. Therefore, you need to sacrifice. It's all about sacrifice. You burn the midnight candle so that you can achieve your aim. By the time you qualify, you will not remember all those pains that you go through. Please, guys, time is going. For each day that pass, you are drawing nearer to the D-Day. So that between now and end of April, you need to build that confidence preparatory to your exam. Because once you get to the end of April, that will be our official end of the diet period. Then you are going to have few days or few weeks to your exams. So guys, please, time is going. Don't think that May is still far. May is right at hand. Change your strategy. If you have not been reading, you just have to double now. Just have to double. Anytime that you want to read and something is distracting you, you must always remember the goal that you want to achieve. You must always remember the money that you have paid. You must remember the sacrifice of every night for you to be able to attend classes. Because if there's any issue, if there's any reference, all the stress, all the pain, all the expenses that you have incurred before, you are going to repeat everything again. And you must avoid that. And that's what I'm telling you. At any time, you must remember that goal that you want to achieve. Is it that you achieve excellence or nothing? That is your aim. You just want to pass your ICAN exam. So whatever that will make you to pass that exam, you just have to do it. Deny yourself. This is not the time for you to be watching Arsenal or Chelsea football. This is not the time for you to be visiting family and friends, going for occasion and all of that every Saturday. You just have to create time for yourself. After you are done with your exam, you can sleep for 24 hours in a day. You can visit any family or friends. You can travel anywhere you like around the world. But right now, you need time to study. You need time to study. God will make it easy for you. I will see you again next week by the grace of God. Good night, everyone.
Good night, sir. Thank you.
Yeah, good night.
Thank you, sir. Good night.
Good
Yeah,
night, sir.
welcome. Good night.
Boss.
Yeah, good night.